Hello everyone. In this video we're going to review a very helpful, very useful, and highly recommended technique for you to solve chemistry problems. And that method is dimensional analysis. Now why is dimensional analysis so useful and so helpful? It's because it's a standard set of procedures that allow you to approach different types of problems in a measured and, no pun intended, and an effective way. Because if you approach all your problems the same and you follow, a set of rules, you can land the correct conversion or the correct answer through minimal amount of excess work, and it makes sure that things are correct as you go. So in order to do dimensional analysis, we have to use conversion factors. We discussed this previously in a previous video, but let's say that a value of x equaled a value of y. But typically there'll be different units. So let's say x grams versus y, I don't know, let's say a new unit, we'll call it bigartons. X grams and y bigartons. I can say then, well, if x grams equals y bigartons, I can set that up as a conversion factor. And I can multiply some value here, which I'll say 100 grams. If I multiply that by y bigartons over x grams, notice how when you set this up, your unit on top here cancels out with the unit on bottom, and whatever you're trying to solve for is what's left alone all by itself. And then you do the math. You multiply across the top and divide from top to bottom. So to solve this, you would take 100 times y divided by x, and you would get your answer. Now I know this seems kind of weird because we're not using numbers, but let's do one that actually deals with numbers. Now, in order to solve these problems, you have to know a couple things. You have to know what you're starting with, what your goal is, what your end game is, and you have to know the conversion factor to get there. Now in this case, there's no conversion factor here. A conversion factor from inches to centimeters is that for every 1 inch, that is going to equal 2.54 centimeters. Okay, so for every 1 inch, that equals 2.54 centimeters. So let's set this up. I'm going to, on the top and on the left, and notice you can set it up like railroad tracks like this. I've seen some teachers do this. You can set it up like this. It's really whatever your comfort preference is. But I'm going to start off with 34 inches. Put that in the top and in the left. 34 inches. I'm now going to set up my conversion factor to cancel out inches and get centimeters. So inches has to go on bottom. So for every 1 inch, and again, the reason I did that is because inches is on top, inches is on bottom, will give me 2.54 centimeters. So I want to put the value that I want to get on top here. So now what do? I take inch on top and inch on bottom, it cancels. It's kind of like if you took x times y divided by x. These would cancel, right? Top and bottom cancel, top and bottom cancel. So I basically have to take 34 times 2.54. And if I open up, handy dandy calculator here, I take 34 times 2.54. It's going to give me 86.36. Now, keep in mind, this is your raw answer, right? What was that value again? Lost it there. 86.36. Okay. So if I have 86.36, this is my raw answer. Is it the correct answer? No. Because whenever you have a digit, or not a digit, but a number, you got to make sure you have units to represent it. Because if you just put 86.36 to a greater, this could mean bananas, it could mean cars, it could mean boats, it could be houses, it could be dollars, it could be anything, right? So you have to specify. So my units here are what's left over. So my units here are 86.36 centimeters. Now, is 86.36 the right value? Is there a way I should round this? Should I make this 86.4? Should I make it 87? What should I do? You do that dependent upon your data initially. So if I only have 2 sig figs here, 34, I need to only have 2 sig figs in my answer. So 8 and 6 is what I'll have, And then I'm going to check the next digit to see if I round it up or if I keep it the same. If the number is 5 or greater, I'm going to round it up. If it's 4 or below, I'm going to keep. Okay. So 86.3, 3 is below 5, so it'll be 86. Now you can put the decimal here, you don't have to. But again, 86 centimeters would be your correct answer there. And lo and behold, that's what we get. Notice here, you have your inches and your inches cancel. You're left with centimeters on top. You get 86 centimeters at the very end. So that's dimensional analysis. Let's do some other quick math, but with temperature. In chemistry, I know that a lot of us use Fahrenheit to tell how hot it is outside, because as we know, a degree where it's 90 degrees versus 70 degrees can make us very happy or very sad depending on what we're doing, right? So in chemistry, we don't really use Fahrenheit because the converting between Fahrenheit and other units, especially since the SI unit is Kelvin, is very complex. You have to use fractions and then adding other values to that as well. Instead, we just use Celsius and Kelvin. So Celsius and things like that, these are often going to be on your instruments. So if you like have a thermometer, you're not going to have a thermometer in Kelvin necessarily unless it's kind of unique. Kelvin is usually the theoretical value. It's like when we talk theory or when we talk about, standards and things like that, we're going to deal with Kelvin. But Celsius is what your instruments are. So we have to find a way to convert these two to one another. So to do that, Kelvin is equal to whatever the Celsius temperature is plus 273. And again, we want to use Kelvin because Kelvin is considered to be an absolute scale, which means Kelvin can never go negative. It can only be positive. Absolute zero, or when Kelvin is equal to 0, is a theoretical value in which the molecules or the atoms of whatever sample you have just stop moving. They totally come to a complete halt, which has never actually been done. It's entirely theoretical, but it's the standard that we use. So let's say, for example, I'm at room temperature, which let's say I'm in a little bit of a warmer room here, 25 degrees Celsius. What's that temperature in Kelvin? I have to plug 25 into my formula here. 25 plus 273 will give me my Kelvin temperature, which in this case is 298 Kelvin. Okay, that's going to wrap up this video.